Okay, so I will start the session from the previous topic, that is object. Okay. Uh, as we have already discussed that what is object. So object is a real world entity, and if you say that um, that object is in existence, so that object will have three things. That is unique identity by which you will identify that object. After that, it will have some state and it will have some behavior also. So what I was telling you before starting the session, that as you know, there are so many approach of the programming. So mostly two approaches are very popular. One, so programming approach, if I say programming approach. So one is called structure programming approach. Do you know the structure programming approach? Yes. So structure programming approach is one kind of programming paradigm or approach, and second is called object-oriented programming approach. Okay, so the structure programming approach follows by C programming, in which you create functions and you create um, uh, modules accordingly, and whenever you require to perform any operation, you call that function. So the main emphasis on this approach is on action. The main emphasis uh, in this approach is on action. Action means we define the functions. But in object-oriented programming approach, we have main emphasis on data. And data, which type of the data? So the data that is the type of instance data. Instance. So instance data. So anyone, do you know what is instance data? Okay, Meng, just tell me what is instance data in programming? Yes, variable inside the class, that is, and it is non-static. So that is called instance data. So just note down the instance data that is declared inside a class and which is non-static. And this data is main emphasis in object-oriented programming. So now come to the topic. The object, that is unique identity, state, and behavior. And to create any variable object, we write the syntax like the class name, then your reference variable. After that, you call new and this my class, and this is your constructor. As we have already seen this is the syntax to create any object. And the definition says object is a real world entity, or you can define any object as object is an instance of a class. Okay, object is an instance of a class. Instance of a class means the whatever you have defined into the class, whenever you create that type of the object, it will have all the attributes, all the state, behavior, all the things it will contain. So from here, we define our class as class is a blueprint. Class is a blueprint for object. It's a blueprint. Okay. So class is a blueprint for objects. So whenever you define any class, you define only the blueprint. And after that, when you create an object, so you create an instance of that class. An object is called instance of the class. And this is called the creation mechanism. Now the question is, which one is object? So make sure that OB is not object. OB is a reference variable, the name of this object. This is called object, this one. When you call a constructor with the new keyword, it creates an object. And this OB is a reference variable. So if from here, as you know, whenever you will create any object with the help of the new keyword, it will be assigned into the memory location that is called heap, because heap is used for the dynamic memory allocation. So this object will be created into the heap, and this object will consist the members that you have declared inside the class. Okay, so I'll design something, just wait, to show you that this is, for example, the heap memory area, and this one is your another is memory area that is called stack. We put all those things, or your computer put all those things which are dynamically changed into the heap memory area, and put the things that is fixed, that is inside the stack. So in the case of this signature, this will create an object. So object will be created inside the heap memory area. So this will create an object of type my class. Okay. And since this object, and Java says the object cannot be accessed directly, so we will access this object with the help of this reference variable, and this reference variable will be created inside your stack like this, OB, and this will be point to this object like this. And whenever a new object will be created, it will contain all the members that you have defined inside the class. So it will have a is equal 20 like this, because inside a class we have defined a variable a and the initial value that is 20, and a method that is show value. This is the way that you create. Now, if you want to access any member of this object, you need to call through this reference. So that's why we write ob.a, then we get a is equal 20. If you call ob.showValue, then it will execute whatever you have written inside your method definition. And make sure object contains only, object holds or contains only the non-static member, non-static data into it. The static data that you have created is not a part of your object. Okay, so static members doesn't encapsulate it into your object. So after this statement, if I call ob.show, So this will call this method, and here you have written that is system.out.println a is equal 20. So it will look into this object because we are calling from OB. So it will look into this object, what is the value of a into this object. So it will find that a is 20. So it will print a is equal 20 and integer b is equal 30. So static, I will tell you that what is the purpose of the static. So b is equal 30, so it will access b is equal 30. Now again, if we start writing and we want to create a new object of the same class type, then we will write the same signature. When we write ob1 is equal new my class, so just note down this point. Whenever this signature came into existence into your code, it will always create a new object into the heap memory area. Wherever you will write this statement, it will create a new object into the heap memory area. And since this is a new object and the name of OB1, so this will create a new object over here, and this will be pointed by a new reference that is called OB1. And again, it will point to this object, and in this way it will also have a is equal 20 and another thing that is show value, like this. Now if I write ob1 dot a, so it will access its own value that is encapsulated inside the object, and show method if we call, then ob1 dot show. So I hope this picture is clear now, and after that I will show you some example to better understand. So just tell me that this picture is clear, then I'll move to the next. Okay, okay, fine. So now what if I write, I'm going to make changes into this code. A is equal a plus 20. Okay, so as you know, this a is here. So when I will call the method, it will execute this line and it will give you the output as a is equal 20. It will give you the output as a is equal 20, and it will produce the output as b is equal 30. And here a is equal a plus 20, so it will make changes and it will become as 40. Agreed? Now if you want to see this, just copy, paste and execute it. Open containing folder in desktop, Java C, that is anything.java. Fine, then run with the my class. Just look at here. A is equal 20, B is equal 30 first time. A is equal 20, B is equal 30 the first time. And after that, if I call, then A is equal 40 and B is equal 30, because we are not making changes into B. I hope this is clear. Now, what if I call ob1 dot show value? If I call ob1 dot show value, so just tell me that what will be the value of A if I call ob1 dot show value, and what will be the value of B if I call ob1 dot show value. Okay. Meng says 2030. 2030. Okay. Justin says 2030. Okay, fine. So since we have created this object, so it will contain all the variable that you declare in our member inside the class. So it will be assigned a as initial value, because when you call this method, it make changes it in its own object. So according to this picture, if we call ob dot show, so it will call this and it will make changes into a that is inside this object. Okay, and it will become 40. Next time when you call ob.show, so it will print 40 because a has been updated. So next time it will become, when you call show, it will be 60. Now it is 60. When you write this statement, it will create a new object into the heap, that is ob1, and initial value of a, as you know, that is defined into the class, that is a is equal 20. So it will assign initial value, that is a is equal 20, to this variable, and when you call this, it will print a value from this object, that is 20, and b is as 30. So you all are good. Your answer is fine. Now tell me, what will be, can we access, can we write this code? Okay. Yes, Ming says yes. Justin says okay, no, and okay. So this, as I said earlier, whenever you will write this statement in your, this is anonymous object Ming. Okay. So whenever you write this statement uh, in your code, as I said earlier, okay, Justin and Hinduja, since you don't know, so just listen very carefully. Whenever you will write this statement in your code, it will create a new object into the heap memory area always. As you write over here, so it will create a new object. As you write over here, so it will create a new object. Okay. So if I write this statement over here, so it will create a new object into heap. But as you know, this doesn't contain any reference, the ID. In the case of this object, it contains OB, the name of the object, the reference of the object. In this case, it also have the name of the object, the reference variable we called it. So in this particular case, we are not assigning any ID. And yesterday I told you that if any object doesn't have unique identity, then it will not exist into the world. So when you write this, this will create object, and this is called anonymous object. Okay, because it doesn't have a name. So this will create object, and after that it will call the method. When it goes to the next line, it will be destroyed. It will not exist into the memory because it doesn't have any ID, unique identity. So for the existence, it must have the unique identity or must have the reference variable. So in this particular case, yes, this code is 100% perfect because this will create object, and with the object you can call the method, but this object is called anonymous. When you move to the next line, it will be destroyed. So to see the output and understand that this is wrong or right, as you see, you can see that this program is compiled perfectly, and when you print it, then a is equal to 20 and b is equal to 30 from the last statement. So this object is called anonymous object. I hope this is clear. So this is called anonymous object. Now, one more thing. If I write my class ob2, and if I write ob2 dot show value, okay, so can we call this method with the ob2 here? Yes. So Induja, what about you? Everyone says no. No. So when you call this method with this reference, so it will show you error, and the error might not have been initialized. That's why it is showing error, that is ob dot show value. Now, only the syntax. So we can write into the next line that this contains the object. After that, this will be fine. You can call this will be called this method. Now this code is perfect. Now I hope this is clear to everyone. Again, one more thing you can do is you can assign an existing object reference to the new created reference. You can write this one also, and this is called aliasing. This is called aliasing. Aliasing means we are creating a new name of the existing object. So in this case, object will be this one, and it will have two names. One is OB and second one is OB1. As you can say, the nickname of any person. Okay. So by which we can identify those person by their actual name, or we can identify, or we can call that person with the nickname also. So this is the object. It has the name OB, and we are creating another name of this object, that is OB2. So this is called object aliasing. So if I call OB2.show, it means we are calling this object. So in this case, only this will be happen in your memory. This will create a new reference variable into the stack, and it will point to the existing object. That is, so come to this code. So if I call ob2.show, so you will see the output, that what is the last produced output is here. So it will take the a value from that output. Just compile and look at the output. As you can see, a is equal 60 and b is equal 30. So this is called object aliasing. I hope this aliasing and anonymous object is clear to everyone. Okay, fine. Now, Java has a feature that is called auto memory management. Okay, as we have seen in the very first session that in Java has a feature that is called auto memory management. So what is auto memory management? Any unreferenced variable. Okay, so auto memory management is about auto memory management is all about unreference unreference variable are eligible for garbage collector. Means there is a utility in JVM that runs, and the purpose of this utility is to see if is there any unreferenced variable is available into the memory. It will collect and it will destroy it. So if you create any variable that is unreferenced, so that will be destroyed by your garbage collector. Okay, so in this case, as you can see, this is anonymous and unreferenced object, so this will be destroyed. If I want to make any object, for example this one or this one, to be destroyed by your Java, so you just need to write ob1 is equal null. So when you assign null to this reference, since this ob1 is pointing, this ob1 is pointing to this object, when we write ob1 is equal null, so now this will point to null, and it will be, this link will be vanished, and after that this object will become unreferenced. So in this case, this object will be destroyed. So this is the concept of auto memory management. That is the feature of your Java. Clear? Okay, good. Now, few things only. These I'm going to make code small, so you will be get more clarity. Okay. Now tell me what will be the output. Is there any error or any output or anything else? Just look at the code and tell me what will be the output. It is compile time error, runtime error, or anything will be show onto the console. So no error. So what will be the output, Ming? If is there is no error, so maybe it will print something. Okay, Meng says it is 0. Okay, fine, Meng. And so okay, now I will not take too much time to explain this point. Um, this is called instance variable. Okay. So what is instance variable? The definition is, I'm going to write this instance variable definition just here. Non-static variable inside a class. Okay, that is called instance variable. So it is non-static and it is inside a class. So this is called instance variable. So any variable, if you create inside the class, is called instance variable technically. So there are some default values for each type of instance variable. Each type means, as we have seen in the previous session, that the primitive data types, there are 8 primitive data types, and we can create any variable of the class type, or we can create any variable of interface type. So any type of the variable that you declare inside a class that is non-static is called instance variable. So every instance variable has its own default values. If you don't assign any value, it will be initialized with its default value. And what are those default values? So default value for, okay, int, I'll start from the byte, short, int, and long. If you declare any variable like only int, byte, short, or long, then the default value is 0. So since we are not assigning any value to this a, so it will be initialized. I was telling you that the default value for byte, short, int, long is 0. In the same way, default values for float and double is 0.0. For character, the default value is, when you will print it, is white space, means it will not show you anything. And default value for boolean is false. Okay, so default value for byte, short, int, long is 0. You are not able to see my screen? Okay. So now this is, I hope, is visible to everyone, that default values for the byte, short, int, and long is 0. Float and double is 0.0. Char is white space, means it will consist, if you print that variable, you will see nothing. And boolean, it is false. By default value is false. And for a reference, if you create any reference variable, it is null. For reference variable, it is null. So as we have seen yesterday, that there are 3 literals which are reserved. One is null, second one is true, and third one is false. So true and false are reserved for the boolean. Null is reserved for the reference variables. So if you create any reference variable inside a class and you are not assigning with the object, so it will assign with the null. If you are creating any variable like a float, double, int, or boolean, and you are not assigning any value to those variable, it will be assigned with default value. So if I write like boolean, for example, boolean b, and since I'm not initializing it, and if I access one more method I am going to discuss you, there is one more method that is called println. Print and println, the difference between print and println is after printing the whole statement, the println will move to the next line automatically. So you don't need to use /n, the special, the escape character. So in this case, if I write b is equal and b, so you can see, I'm going to compile and execute. First of all, compile it and then execute it. So as you can see, a is equal 0. Since we are not initializing with any value, and as we know that the default value of int is 0, so it will be initialized with 0. And boolean b, since the b is the type of boolean, so its default value is false. So as you can see, it will be initialized with false. And in the same way, if I write a string and s, and we are not initializing s with any value, and if we print it, for example, s, and here is s, come to the compilation and look at the output. So s is assigned with the null value. So this is the default values for variables. I hope this one is clear. And these default values works only for the non-local variables. Local variables will not be initialized with any default values. Okay. What I mean to say, if I write int a over here, and if I want to access this variable into this method, since this is not initialized over here and it is a local variable, so you will get error. So default values are for non-local variables, means that you declare inside a class. This is called default values. So is it clear to everyone that the default values and the local variable differences? Okay, fine. Okay, good. So now come to the next part. So these are the few concepts for the coding. I hope this will help you to write the code. Now come to the next, that is language fundamental 2 part, second part I will say. So here a definition of the static members of the class. So if you declare any member as a static in a class, is called a static member of the class. And the static members are not particular to any object, as we have, as I told you earlier, that only the non-static variable will be encapsulated into your object. So static members are not particular to any object. They are accessed with just the class name. You don't need to create any object because they are not particular to any object. So we can access static members direct with the class name. As you can see here, there is a class name that is math, and there is a variable public static final float pi is equal 3.14f. So if I need to access this pi, then we don't need to create any object of type math. We can access this pi with the class name direct, as you can see here. So math.pi. So in the case of a static member, you don't need to create any object. You can call those members direct with the class name. Clear? Now, Which members you can create as static? So you can create static data fields, either variable or constants, into the class. Methods, you can define the static. Nested class you can define as a static. We'll see later what is nested class and how to declare it. A static nested interfaces means you can create nested interface also as a static. And static members gets initialized. This point is important. Static members gets initialized into the memory when the class is loaded. Okay. Static members gets initialized into the memory when class is loaded. And since for the execution class is class load only one time, so static members initialize only once and it has only one copy. It has only one copy that is shared by all objects. Static members has only one copy that is shared by all objects. So we'll see with the example. What does it mean? Just look at here. If I write integer a is equal 10, and if I declare a static integer b is equal 20, since this is a static, so I'll delete and this is statement also. B is equal b, and then I write a statement a is equal a plus 5, and b is equal b plus 10. Okay. Now create an object that is ob new my class and call ob.show. After that, I'm going to write one more time this statement. This is ob1 and this is ob1. So when this line will execute, this will create an object and it will encapsulate a member a is as 10 and method show. So when you call ob.show value, it will access a as 10 and b as 20. And after that, it will make changes a into a. So it will become 15 and b will become 30. After that, when it comes to this line, it will create a new object. And in this new object, it will encapsulate a as 10. And when you call this, so it will access the a value that is encapsulated inside this object. So it will print a is as 10, but since b has only one copy and it initialize only once, so it will be print b as 30, not 20. Like this. So as you can see, a is non-static, so it will be assigned to every object, but b is non-static, so it is common to all objects. So if any object makes changes into any static variable, then it will be reflect into the only one copy, and when you access with this object, it will get the updated value. So this is the purpose of static. If you need that a member should have only one copy in your code and it should be common for all, so declare those members as static. And static members are not particular to any object, so you can access this object direct with the class name. Now come to few points. These points you must remember. First point says a static method can access other static members, data or method in the same class directly. The first point says a static method can access other static members, either that is data member or that is a method in the class directly. So if I want to access this B into this method, that is main, so I don't need to create any object. I can access this B direct into this method like this. Why? Because the rule says any static method, this method is static, as you can see, can access any static data member or any static method direct into the same class. Or if you write this syntax, so it is also fine. My class dot b. It is also fine. But since we are in the same class, so we can access direct with. The meaning of this statement is this point. Okay. Next one is a static method cannot access non-static members of the class directly. Object is required. So if you want to access any non-static member, for example, this A or this show value into a static method. So first of all, you need to create an object. As we have already seen, and we have already done so many examples over on it, that if we want to access show value into the main, since main is static, first of all we create an object, then we access this member like this. So if I write ob is equal new my class, and then we call ob dot show value. Fine. So static can access static members directly. For non-static, object is required. And the third point is important, that in a static method, we cannot use this and super. This and super are predefined references or objects, you can say. So this and super cannot be used in a static method. So I hope these 3 points are clear to everyone. Okay. One more thing is available into Java programming, that is called Initializer Block. What is Initializer Block? Initializer Block means this. I will delete some piece of the code to make clear. Actually, this is called block, a pair of curly braces. This is called block. So if you create any block into the class and marked that block as a static, this is called a static initializer block. And whatever the code, whatever the logic you want to write, you can write into the static initializer block, and it will be automatically called when your class is loaded into the memory. So I will write only one statement, that is system dot out dot println, that is I am static block, and one more statement into the main, that is system.out.println I am main method block. Okay, so just look at the output of this code. So you will, okay, I guess M is missing. Fine. So you can see that this static block gets executed very first. And after that, your main method is going to be execute. So static initializer blocks automatically gets executed when your code, your class is loaded into the memory. And as we know that is static initialize only once, so this block will execute only once. And whatever the code you want to write, that should be executed at the time of class loading, so you can put into static initializer blocks. So I hope this static initializer block is also clear. Next one is non-static members. So previously we have seen any member that is marked, that is not marked as a static is called non-static member of the class. And we can create any instance data fields, instance methods, inner classes, and non-static nested interfaces of these type, this type that is non-static. So non-static members are particular to an instance of the class, so also called as instance members. So we call non-static members as instance members. So here, as you can see, there is a class as here mentioned in the slide, that is class monitor, and there is a variable private string model number. So this is non-static. So model number is non-static data member instance field, and this method is called non-static method. So it is called instance method. So field model number is instance data field, and method this set model number and get model number are instance method. So if you need to access these, then object is required. For the accessing, these three actually these 2 points are important. A non-static method can access other static and non-static method in the same class directly. So if you have a non-static method, it can access static or non-static, both methods or data members directly in the same class. So what it means into the code, we'll see where is, okay, here. So I'm going to delete it. Integer A and a static integer B. If you have a method that is non-static, void show, and if I want to access system.out.println A is equal plus A plus B is equal B. So it can access direct A and B. Why? Because a non-static method can access static and non-static members directly in the same class. The rule says, just look at here, a non-static method can access other static and non-static methods in the same class directly, or members you can access directly. So if I compile and run it, let's see compile it. So we'll see that this method gets executed. We are not getting any error. When we call this show method, then we'll get the output of A and B's printing. So I hope this point is also clear. And the last one, the last point of this slide is a non-static method is implicitly provides 2 references. One is called this and second one is called super. Super represents the parent of class, and this represents the current object of the class. So how do we use this and super? Today I will tell you this only, and then after 1 and 2 session we'll discuss the super, when we will cover the inheritance, because in inheritance we create parent and child relationship, and in that case we can access the super. But currently we are writing only one class in our code. So in this case we will I will discuss only this over here. So what is this? Just delete the static, this one. In Java, this is perfectly all right. If I write integer a like this, fine, and I want to initialize, this will not show any error, because Java, this is the reference, sorry, instance variable, and this is the local variable for the method. So you can create the same name for the reference, sorry, instance variable and the local variable. What if I want to initialize this a with this variable? Okay, so when we create any object, for example, my class ob is equal new my class, and if I access ob dot show, so if we want to access the a that is encapsulated inside this object, we can access into the method by using this. So if I write this dot a, so it will point to this variable, that is a. And if I write a, so this is the local variable which is over here. Fine. So to access any instance data member into the non-static method, we can access through this, and this will access the calling object's value. So since we are calling the show method with this object, so it will access the value that is encapsulated inside this object. So if I write system dot out dot print ln, and I will write instance a is equal a, this one. Let's copy it and paste, and I will write local a and this one. So if I need to call this show method, I need to pass any variable value. So I will pass any value, that is 12. And now write this dot a like this. Now look at the code. This show method is accepting a value by a. So this will become a local variable. So if I need to access the local variable, I will write only the name. But if I need to access the instance variable inside this method, we will write this dot a. So now look at the output. So instance a value is 0 and the local a value is 12. So this is the way that we use this to access instance data member inside a non-static method. So I hope this point is also clear, that this is by default available into non-static method. Super is also available, but we'll see after inheritance. Next is a non-static block of code. It is also called non-static initializer block. As we have already seen that static initializer block. So how do we create it? We create a static initializer block in our class by creating any block marked as static. Now, if you create any block in your code, which is simply write like this, so this is called non-static initializer block. Non-static initializer block. And this is called static initializer block. Okay. So a static initializer block gets executed when your class is loaded into the memory, and it gets executed only once. But non-static initializer block gets executed every time whenever you create an object of this class type. So to see that this block is getting executed or not, I will write system.out.println, and here I will write I am non-static initializer block. I will delete. Now code. Okay, one more thing. Make one more statement into this block, that's system.out.println, and here I will write non-static initializer block. This. Now look at the output. Compile. Okay. This code should be inside here. Fine. Now run it. Okay. Sorry, I have written some wrong statement over here. That's why. So this block is a static block. So I will write a static initializer block, and in non-static initializer block, I am writing I am non-static initializer block. The statement was wrong. That's why we are getting a static initializer block. As you can see, gets executed very fast, and after that, when you create an object of this type, it gets executed automatically. That is, I am non-static initializer block. So if I create the object of this class as many as number of times, this non-static initializer block will execute that number of times. As you can see, a static initializer block only once, but non-static block gets executed 2 times. Why? Because we are creating an object of this class 2 times. One is here and second one is here. So what is the use of this? So if you want that some piece of code should run at the time of class loading, then you will put into the static initializer block. And if you want that some piece of code should be executed at the time of object creation, we will put inside the non-static initializer block. So this is the purpose, and when you will go into the actual implementation, you will see that why we use this coding, these blocks. So only just understand the concept of these static and non-static initializer blocks. So constructor, we'll see constructor in the next session. This is a fresh topic, and it will take time to cover it up. So that's why I will tell you the constructor in the next session. So I hope all the topics that we have covered today is clear to everyone. Now, if you have any doubts, any queries related to these topics, so you can ask, tell me. Okay. Yes, Justin and Hinduja, do you have any query? Okay, fine, Hinduja. Then Justin. Okay, good. Sorry. So after completion of a few topics like constructor and polymorphism, I will give you some assignment. Okay. So tomorrow I will give you some assignment that you will complete by yourself, and after that you will submit to me on. I will give you that link that where you will submit those assignments. And uh, uh, we have already covered so many things today. So just revise it once, and when you come to the next session, we'll start from here. So today's session I'll bind up over here. Fine. Okay, so see you tomorrow at 8:30 p.m. IST. Okay, thank you. Thank you for joining this session. Thank you so much. Bye bye.